Hello everyone, welcome to the world of data structures. But today's topic is queue implementation using linked list. Hi, this is your instructor Janice Shaw. So let's begin with the queue implementation using linked list. Students, our today's outlines are: first we are going to understand about the concept of the queue, then we'll understand the insertion and deletion in simple queue by using linked list. Fine. So let's begin. So first, this is my queue, students. If you remember the queue using array, we are representing with the two different pointers. First we have the front. Front is known as a pointer which is used for the deletion purpose, and rear is used for the insertion purpose. Here I have total 5 elements in the queue. Out of 5 size of the queue, we have 3 elements like 10, 20 and 30. So obviously front is pointing at 10 and rear is pointing at 30. Now, if I want to represent the same thing by using linked list, I can do like this. Here I have the converted linked list. Only 3 elements. See, linked list occupies the size the same as the number of elements are there. Okay, that's why the 10, 20 and 30, 3 elements are there. It is very much easy to implement a queue over here because we have the pointer for the first node and the last node both. Our very first node is known as the front pointer, which is pointed by the front pointer, and the last node is pointed by the rear pointer. Fine. Here the link of the rear pointer is always pointed to null because this is a singly linked list. Fine. Now let's understand how can we perform the insertion operation in queue. Okay. So students, have you ever seen the figure before this? That see, this is after 30. Okay, so now just tell me, students, if I want to insert anything in the queue, what I need to do is I need to insert at the rear end. Yes or no? I need to insert at the rear end. So rear end is at 30. Okay, so whatever the element I want to insert, I just need to insert on the right side of the rear. That means at the last node of the linked list. Fine. So students, insertion in simple queue is similar as the insertion at last in single linked list. Fine. But here we have the convenience that we do not need to do the traversing from the first node to the last node because we have the name for the both side. At the first side we have the front pointer, and the last side we have the rear pointer. So we do not worry about it for the traversing. We just need to focus on our algorithms only. So here students, first we have take a new node from the already stack. Okay, you all are now master in that. So just take a new node from the already stack. Here it is my new node. Its value is y, and its pointer is pointing to the null. Why? Because after inserting this new node, it is obviously inserted at the last. So the link of the new node must be at null. Now, what I need to do is I just need to put this new node on the right side of the rear. So I have just done it. Now what to do? Just connect the link of the rear to new. Link of the rear to new. So perform only 2 steps are there, students. Number 1, connect the link of the rear to new. That is link of R arrow new. So here it is, link of R arrow new. So that link of R is connected to new. Fine. Now the next step is students, the R is going to see up now which one is your R is going to be incremented. If you know R is incremented, but here we cannot write like this R is equal to R plus plus. So we just need to move our R to the next node. That means R arrow link of R. Fine. So this is my last step, that is R arrow link of R. Okay. Instead of that, you can also write like this R arrow new. Both are the same thing. R arrow link of R or R arrow new. These both are the same thing. Fine. So students, this is how you can perform the insertion operation in simple queue by using linked list. So let's see the algorithm for it. So first, check the underflow. If avail is equal to null, then you cannot insert a new node. Then avail new is equal to avail. Avail is equal to link of avail. So all 3 steps are very much common over here. Next, what happens? The first one is, see, initialize the info of the new nodes. Students, we already know that we are going to insert a new node at the last of the queue. So you can initialize both of them. Info of new is equal to y and link of new is equal to null. Info of new is equal to y, link of new is equal to null. Then just need to move the links over there. So first, if f is equal to null, the first situation, students, if linked list does not exist, if linked list does not exist, then what happens? Students, if linked list does not exist, then the front and rear are both pointing to null. That means if f is equal to null, then linked list does not exist. In this situation, whatever the node you have, it becomes your first node, it becomes your last node. So just need to write f is equal to r is equal to new. That means f arrow r arrow new. Fine. So it's done. Else, if linked list exists, then you just need to take a very first step. That is, link of r need to connect to new. So here it is. Link of r is connected to new, and then r to new. Next step is r arrow new. Okay, so such like this you can perform the insertion operation in simple queue, which is implemented by linked list. Okay, so let's talk about the next program, that is deletion in simple queue. So students, when we talk about the deletion in simple queue implemented using linked list, so what does it mean? When you just want to delete a node from the first side of the linked list. So here it is very much easy, because you just need to move your front pointer, to its next node, and your first node is already deleted. So it is same as the deletion of the top. Okay, is it same as the deletion of the stack, like pop operation? Here this is the same as like that, where we need to perform the deletion operation in simple queue by using linked list. We just need to remove its first node only, nothing else. So here it is. First assign temporary to front. And then move front to link of front. Okay, so only in 2 steps you have completed your deletion operation. Isn't it easy? Okay, so now it is very much clear that how can we perform the linked list insertion or deletion operation in queue and stack both. Okay, so after deletion, what happens? What we need to do is we just need to move this to the availability stack again. So your node is gone and deleted. Let's check out the algorithm for the same. So here we have the first one, underflow condition. Check out whether my linked list exists or not. Students, if my linked list is not exist, then we need to move further. So first check if f is equal to null, then just write q is underflow. You cannot delete anything. If it's not like that, then the first assign temporarily to front. So temp is pointing to front. Then next step, delete the info. So before deleting, we just want info of this. Okay, and right now we are returning something over here. Okay, so here y is arrow info of f. So y contains only information that what we have deleted. Okay, so y contains the information of f. Next, students, what we have to check that whether during the deletion, if my f and r both pointing to the same position or not. So what you need to check, whether your f and r both pointing to the same position or not. Students, if your f and r both pointing to the same position, then your queue becomes empty. And at this situation, you need to move your front and rear to none. Okay, so if my f is equal to r, then I need to write f arrow r arrow null. Next step, if both the condition get false, students, then we need to move forward to the next step. And the next step is that, so here students, this is our repeated step where we just check out that if front is equal to r, then just move towards the null and then return y. After it, we just need to check if it's not like that, then what we need to do is, students, else f arrow link of f. That front pointer is moving further. And at last, we just need to restore temp. Okay, so students, this is how you can perform the deletion operation in simple queue. So what we done today, that simple queue deletion by implemented using linked list, in which the deletion operation is similar like deletion in the linked list from the first. Okay, and the insertion operation is similar like insert at the last in the linked list. Fine. This is all about the simple queue insertion deletion. Same like that, With the same concept, you can do insert and deletion in circular queue and priority queue, or we can say DQ also. So that's it. Thank you so much.